Welcome back. Today we're moving on to lesson 1-3. Lesson 1-3 is all about algebraic expressions, and specifically we're going to be talking about wanting to evaluate algebraic expressions and be able to simplify algebraic expressions. So, the first thing is, how do we write algebraic expressions? So I'm going to be able to describe something to you in sentence form, and I'm going to ask you to be able to mathematically write it. So, first thing that you want to do is identify the words that identify an operation. So what that means is if you see the word sum or total, that's going to tell you you're adding. If you see terms like less than or fewer, that should clue you in that you're subtracting. If you see the term product, you should realize that you're multiplying. Division, or sorry, quotient, means that you're looking at division. So the first key is, can you identify the language that shows you which operation you're going to be using? Okay, that's going to be the first step. After you've done that, then you're going to want to decide on the order the operations. Now, that may sound silly, but there actually is some circumstances that you write in a different way than you read it. Okay, so let me give you a few examples of how this looks. Which algebraic expression models the word phrase 7 fewer than a number t? First thing I'm noticing is fewer than. So fewer than tells me that I am subtracting, okay? That I'm going to be using the minus sign. Now, the thing that's tricky about fewer than, or you could replace that with less than, is let me give you an example. Take 7 less than your age. Okay, so you're not taking 7 minus your age. 7 less than your age is you actually start with your age and then subtract 7 from it. Okay, so using more context around it, I think is much easier to see that you're starting with the t and taking 7 away from it, okay? So that's why I caution you to think about the order, because sometimes you actually do the operation not in the order that it's written, okay? You have to process it a little bit for me. Now, what about this? 2 times the sum of A and B. So times is obviously going to be multiplication. Sum is going to be addition. So here we have 2 operations happening, okay? So I have the sum of A and B, and I need 2 times that quantity. Well, some people will just put a 2 there and call it good. But that's not going to be 2 times the quantity A plus B. That's just going to take 2 times A, then add B at the end. So you need to be smarter than how you write it, okay? Because you know what you're thinking, but it's not what you're communicating to me until you group the A and the B, okay? Because that's going to take the sum of that quantity, multiply that whole thing by 2, giving you answer C once again. All right, so just be careful that you know and that you're showing exactly what you mean, okay? Because it's very easy to slip up and just not writing one of those few things could make a big difference. All right, what about some more complex ones, okay? So to model a situation using an algebraic expression, identify the actions that suggest operations, define one or more variables to represent the unknown or unknowns, represent the actions using the variables and the operations. All right, so for example, let's say you buy a car that already has 40,000 miles on it. You drive an average of 30,000 miles in a year. Write it in algebraic expression that models this situation. Okay, so here I'm going to let X represent number of years. Okay, so what's happening? Well, I'm starting with 40,000 miles. Okay, that's how many it has when I buy it. And then I'm putting on 30,000 miles each year, okay? So that process of adding on that many each year, That's what connects it to that variable. So after 1 year, I'm adding 30,000 miles. After 2 years, I'll have added 60,000 miles. After 3 years, I'll have added 90,000 miles. Okay? So make sure that you understand that structure of if you're given an initial value and then how that initial value is changing. By what rate is it changing? Okay? You'll see a lot of that coming up in chapter 2. A lot more examples like these. You had $150, but you're spending $2 each day. What algebraic expression models this situation? So again, I'm just going to label X. It's going to be number of days. Okay, so I'm starting with that 150. I'm spending $2 each day. So this time I'm decreasing the value. Okay, I'm decreasing by 2 every single day. So again, I'm looking at my initial value and then the rate at which it's changing. And the rate is what takes on the variable. All right, so just a couple common examples of how you can apply these to more real life situations, okay? What about evaluating these expressions, okay? So now that we can write them, let's talk about how to evaluate them. So evaluating, all that means is you're substituting in a given value for the variables and calculating the solution, okay? Now the important thing is when you're calculating is you're using the order of operations, or as you know it, PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. Now, one of my key points here that I always recommend to my students is um, use extra parentheses. Okay, whenever you substitute in a number when you're evaluating, put an extra set of parentheses around it, because that way when you type it in the calculator, you'll be much more likely to get the right answer. Okay, sometimes you have to be smarter than the calculator. So, let's do some of these examples. Let's evaluate these. So, looking at this, A is going to be -4, B is going to be 5. So I'm just going to rewrite this. And again, just to be safe, I'm going to put in extra sets of parentheses around every number that I plug in. Okay? So now let's go through the step-by-step process. First is parentheses. Well, I started with this initial set of parentheses, okay, the A plus 4. So that's where I'm going to start. -4 plus 4 is going to be 0. Next up, exponents, but we don't have any. Then multiplication and division. So I'm going to take care of those. And now finally addition and subtraction. And I get my answer of 7. All right, next one. So again, I look to see what I'm plugging in, and I always put them in an extra set of parentheses. So x divided by y plus y squared. Okay, so here there were no original parentheses, so I don't have to worry about that. Exponents. So exponents, I see a squared there. So I'm going to go to my calculator. Okay, 1/2 squared. And again, this is where it's very important that you have the parentheses around the 1/2. 1/2 squared is going to be 0.25. So I have 1 over 1/2 plus 0.25. So I've taken care of my exponent. Now I'm going to take care of that division. 1 divided by 1/2. Once again, is very important as you type it in the calculator. Make sure you are including those parentheses that I've told you to add in. When you type in 1 divided by 1/2, using those proper parentheses, you get 2. Well, 2 plus 0.25 gives you a final answer of 2.25. All right, and our last example for this page. Again, all I'm going to do, write those in. All right, so I have initial parentheses right here. So I'm going to focus on taking care of that first. Now, the order of operations within the parenthesis, I see exponents and subtraction within the parenthesis. So I'm going to start with the exponents in there, okay? 6 squared is 36 minus negative 3 squared. And again, this is where it's very important if you type it in the calculator that you have those parentheses. Negative 3 squared is 9. All right, so now to finish off that parenthesis, 36 minus 9 is 27. So now I'm going to finish off the top. 2 times 27 gives me 54. Divide 54 by 3 gives me 18 as my final answer. Okay, so again, all it is just being very diligent with the order of operations and remembering those extra parentheses for me. All right, so let's take a look at combining those two skills. So now we know how to write them, we know how to evaluate them. What if I asked you to do both? Okay, so ticket prices for admission to a museum are $8 for adults, $5 for, or $5 for seniors, $5 for children, $6 for seniors. And I want to write an algebraic model to represent this. So I'm going to let A be the number of adults, C be the number of children, and S be the number of seniors, okay? So how much are these people spending? Well, they're spending $8 for every adult, $5 for each child, $6 for each senior, okay? But again, it's important that you label what they mean because otherwise those letters don't mean anything unless you label them for me. So that's going to be the total number of dollars spent, okay? Now, the evaluating step. So what if we spend $20 on adult tickets, or sorry, we buy 20 adult tickets, 16 children tickets, and 10 senior tickets, okay? So if that's the case, well now I spend 160 on the adults, 80 on the children, 60 on the seniors. So that's going to add up. They're going to have spent $300 for those tickets. All right. How about a basketball example? So in basketball, teams can score by making 2-point shots, 3-point shots, or 1-point free throw shots. What algebraic expression models the total number of points that a basketball team scores in a game? So here it's important that you label what you're talking about. So here I'm going to let X be the number of 2-point shots they make, Y be the number of 3-point shots they make, and Z represent the number of free throw shots that they make. So their total score, they're making 2 points for every 2-point shot. They're getting 3 points for every 3-point shot. They're getting 1 point for every free throw shot. So this actually looks very similar to what we just did for the first one, right? So now let's take a look. Let's say they make 10 of those 2-point shots, 5 3-point shots, oh, not equals, I'm sorry, and 7 free throw shots. So 20 points plus 15 points plus 7 points. You add that all up, and this team will have gotten 42 points that game. All right. Now, one last skill that I want to cover here at the end of the notes, okay, is simplifying expressions. Now, this is something, again, you saw back in Expo. I'm sure you did in geometry. So I know it's not new, but it is something I just want to take a few minutes here just to reiterate with you. That like terms, they have the same variables to the same powers. And when that's the case, you can combine them to make it look a little bit nicer. Okay? So simplify the following expressions by combining like terms. So in this first one, I'm going to start right here. I see a 7x squared and I'm taking off a 4x squared. So I have the same variable to the same exponent. So I can simply subtract those. 7 minus 4 gives me 3 of those x squareds. Here, both of these are y squareds. Same variable, same power. So 3 plus 2 will give me 5 of them. Okay? So it's really as simple as that. Now, it does get a little bit more complicated. So for example, here, sometimes you'll have to distribute first. So distribute that negative, distribute the 2, and now I can start cleaning it up. So negative 3k plus 2k, well, negative 3 plus 2 is a negative 1. Then here, negative 1 minus 8 more is going to be a negative 9m. All right. Now, what about this one? Well, here, the k, I don't see anything that combines with the k. I also don't see any other just j's. The only thing here that I'm seeing that can combine are the j squared. So remember, same variable to the same power is what it takes in order to combine them. So here, negative 4 plus 1 will leave me with a negative 3j squared. All right, so lots of quality stuff in the notes today. So now that we've finished going through them, my expectation is please take a minute or two here and write a good summary for me, okay? Just revamp something you learned, something you maybe still have a question on, anything like that. Put it in the summary for me, and then I will check over your notes tomorrow and we will move on to our practice work.